So hello everyone. I think it's audible for you, right? So welcome to our stream. Alright, so this is day 4 actually. From past 3 days we were solving just easy problems, but today we are here solving a medium problem, not just so much of hard actually. Now let me go to the fourth problem of this, the interview 150 series, right? So let us see. So we are going with an integer array nums sorted in non-decreasing. That means we can have duplicates and it might be increasing, right? Non-decreasing order means it can have duplicates. Remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. So the order should be kept the same. That's the first thing we need to be careful with, right? So, okay. Since it is impossible to change the length of the array in some languages, we must instead have the result replaced in first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements, that's the same thing which we are solving from the past 3 days, I think so, right? Let me tell you how it works. Just take, let's just see it, right? So, one second. So we are going with 1, 1, 1, 2, 2, 3 for several times, and then 6 for one time, and 7 for 3 times. Now, what we have to do is just change it such a way that 1 and then 1, 2 and then 2, at most 2 times, 3 and then 3, right? Only 2 times. We are just taking 2 times, 6, at most 2 times, 6, and then 7, and then 7. And the remaining we don't care actually. Remaining we don't care. So how can I do this is, if you see this point, when I'm at this point, let me say this as I, and let me say it as index. Now the count, oh God, count count will be 0. Then, as I have 1, I'll just increment the count to 1. Then the I goes here. So, if you see, if this I or nums of I is equal to nums of index, then I'll just increment the count and nums of index will be nums of I. Then I'll increment the I pointer to here. Now, nums of I is equal to nums of index. But if you see, the count is 2, right? So this is the problem that we are solving. But if you see the count is 2, so we do not take it. We'll just increment our I pointer. Now, nums of I is not equal to nums of index, right? So what we do at this point, we'll just change the count to 1 and we'll just increase index, right? Increment the index and then uh, we'll just say nums of index is equal to nums of I, right? So we have initialized it. Then move I pointer, then move index. If you see nums of I is equal to nums of index. Let me tell you, let us just not increment our index. So nums of I is equal to nums of index, which we are having at this point. Now, are they both same? Yes. So we'll increment the count and we will just then increment the index and then keep 2 here. Then what we do, we'll just increment our I. Now, is 3 equal to nums of index? No. So if nums of I is equal to nums of index and count is less than 2, we'll do one thing. Count will be incremented and index will be incremented. Then nums of index will be equal to nums of I. Now, this is the only case which we are referring to. Let us take the example again. Let us take the example again. Triple one, right? Triple one, double two, double three, double three, double two, double three, double three, and then six, and then seven for three times. So I'm just saying that index will be -1. Okay, I think there won't be something like -1. Okay, -1. Let's take it as -1. So we need to write another case if index is equal to -1. We'll just say that index will be incremented. So let us start with index is equal to 0. If index is equal to 0, nums of index is equal to nums of 0, right? So that's it. If and then we'll just continue. We don't check any of this. Now we have made it to here nums of 0. So this is where I have my index and my I pointer will be incremented. Now nums of I is equal to nums of index and count is less than 2. Now here let me say the count is 1. Let me say the count is 1. I'm just changing the count to 1. Now nums of I is equal to nums of index and count is less than 2. So count will be incremented to 2 and index will be here. So nums of index is equal to nums of I, so 1 is fixed here, and then my I pointer will be implemented. If nums of I is equal to nums of index, yes, and count is less than 2, no, it is equal to 2. So what we are gonna do now, we won't be doing anything, we'll just increment the I pointer. No, nums of I is not equal to index. So what we do here is else if nums of I is not equal to nums of index, nums of index. So at this point, nums of I is not equal to nums of index. We just do one thing. We'll just make count as 1. Then we do one thing. We are taking it like this, right? So index will be incremented and the nums of index is equal to nums of I. That's it. So yes, index will be incremented, but before that count will be made as 1 here. I'm just changing it to 2 and I will be incremented. So that's it, I think. But let us check. That this might not be the idea that works for this problem. So int n is equal to nums dot size, index is equal to 0, count is equal to 0. That's it. For int I is equal to 0, I is less than I plus plus I plus plus. If index is equal to 0, then so nums of index will automatically be nums of 0, right? So, but before that, count will be made as 1 and continue. Then, if nums of I is equal to nums of index and count is less than 2. Then we do one thing. Count will be incremented and index will be incremented. Then nums of index will be equal to nums of I. Else, if nums of I is not equal to nums of index, then count will be made as 1, then index will be incremented. Nums of index is equal to nums of I. Then we'll just return index. Oh God, I think I don't know why it is not printing anything. For auto x in nums, let us print c out x. Okay, we got it wrong. I think we can just solve this with an unordered map. Unordered, let's take just map int comma int mp for auto x in nums mp of x plus plus. Now we do one thing. For auto x comma frequency in mp, we'll just do one thing. We'll just see int index is equal to 0 for 2 times. So if f is equal to 1, the nums of index will be x. Else, if not, f would be greater than 1. Then nums of, after that I need to increment the index. Nums of index will be x, and then index will be incremented, and then nums of index will be x, and oh my god, that's it. Will be incremented and return index at the end. I think, and yeah, I was taking it again and again. That's how we end up solving this problem. I think there are similar problems. Let's look. This is already solved in this. So I think that's all for today. That's all for today. I think there is no other thing that's left for today that hasn't been discussed. You can ask your docs, right? So I'm just